I finally got my longer cord, guys, so hopefully I won't trip and kill myself. I'm gonna have to tape it to the floor, but we're close. We can make it work here. All right. So introduction for reactions. So first of all, we need to talk about, and this is going to bop me out. I know it is because it always does. I'm going to drag this thing. Yeah. All right, here we go. So first of all, we need to talk about the difference between physical and chemical changes and the difference between mixtures and pure substances. Okay? So mixtures have a variable composition. So for example, salt water. Derek was in the great state of Utah with the Great Salt Lake there. Very, very salty. The salt level there in that salt water is different from the amount of salt that's in like the Atlantic Ocean. You can actually, from what I understand, and you can correct me if I'm wrong, you can actually float in the Great Salt Lake because your buoyancy, your density is less than that salt water, so you can float in there. It's kind of a weird feature. Have you ever? You haven't gone? Do people swim in that water? I don't know. Do they? Okay, I don't. Yeah, I have no idea. So that salt water is still salt water though. So it's still salty, just like the Atlantic Ocean. It's just a different amount. That is a mixture. We could use physical means to separate that water. So we could boil the water away and have the salt left behind. That is a physical change. Remember, all phase changes are physical changes. Okay? There are a couple different types of mixtures. There are homogeneous mixtures. These are also known as solutions. Yes. Okay. They have very tiny, teeny parts to them. And because of that, they're able to mix well together and they have indistinguishable parts. You can't tell the sodium ions from the chlorine ions from the water molecules in salt water. Okay. Heterogeneous mixtures, though, have very distinguishable parts or visibly distinguishable. Now, these are also colloids, and with the colloids, they're not always as easy to distinguish, but, you know, if you let them sit for a while, they are going to settle out over time. That's why, like, if you let Jell-O sit in the fridge for several weeks, you're going to end up with water on top and the Jell-O kind of in the bottom, okay? If you let paint sit for a while, it will settle out. It's not going to be as rapidly as like sand and water, but it does happen. That's why they give you the paint stick to store the stuff up with. Okay. Now, pure substance. So we talked about ratios here. Pure substances then have a constant composition. We have two different types. We have compounds and we have elements. These, if you change the ratios of these, you no longer have that substance. So water is H2O, but if you change that and make it H2O2, you don't have water anymore. You have hydrogen peroxide. Okay, very different things. Water you got to drink all the time. Hydrogen peroxide you drink and it's just bad. You guys just don't do it. You're puking your guts out. Do you have experience? No, but my previous dog did. He got my medicine and chewed up the whole bottle and ate the pills inside. And so I called the vet and I'm like, he's like, yeah, you need to make him throw up. And he's like, do you know how? And I'm thinking, and he's like, no, there's an easier way. Just give him a couple tablespoons of peroxide, make sure he's outside. And sure enough, like 2-3 minutes later, everything's up. So yeah, it's not a good thing, guys. I do not encourage you to drink that. Now, elements have a set ratio or a set amount, what is their set amount that distinguishes them one from another? Protons, yeah. So each element has a different amount of protons. It doesn't matter where you go in the universe. Those protons are going to be the same. And that's what, they're able to identify these elements far off by using those spectrum, the emission spectrum. So they can see that the sun has hydrogen and helium because they can use the emission spectrum to figure that out. So those are your pure substances, which are your compounds and elements. All right. Matter can be broken down into the mixtures, and then those are the heterogeneous, homogeneous. And then we have our pure substances, which are elements and compounds. The smallest amount of an element that still has the properties of that element is atoms. And compounds, you're either going to have formula units, which is for your ionic compounds, or molecules, which would be the smallest component of molecular compound. Okay, covalently bonded compound. So if you're ionic substances, the simplest thing is a formula unit, which would be like for sodium chloride would be a sodium ion and a chlorine ion. And then for molecular compounds, it would be a molecule, like you're covalently bonded. Okay? So that kind of summarizes that a little bit. Physical changes then, several types of those. Again, all phase changes are physical changes. So if you're talking about your deposition, if you're talking about sublimation, it doesn't matter. If it's a phase change, it's a physical change. Because what are you reducing or increasing when you go through those phase changes?
Speed of the molecule.
Well, the speed's changing, but during the phase change itself, the temperature stays the same. So what is changing during that phase change? What characteristic of the thing? Not bonds, because that would be a chemical change.
Molecules are away from each other.
Okay, but what interaction is it? IMFs, right. You're either increasing the IMFs if you are going through and doing deposition, freezing, or condensing. Annalie, can you modify that blind so Andrew is happy again? Thank you. If you are going through vaporization, sublimation, or what else am I missing there? Nope. Sublimation, vaporization, and what's the third one? Melting. Yes. Then what is happening to your IMFs? They're decreasing. Yes. Okay. So that's what's happening during the phase change. You are not changing the molecules. You're not rearranging atoms. You're rearranging the molecules or the IMFs. Or you're just changing the IMFs. Okay. So these are those phase changes. Other examples of phase changes then include separation of mixtures, and we can separate using a variety of different things. We looked at that in Unit 3, where we had our chromatography, we had distillation. You can do it manually, like when you're eating your Skittles and you're picking out the bad ones first and eating those first, the yellow and the green.
That's true.
No, orange, then purple, then red, because the red's the best. Grape is not gross. Okay, other phase changes: cutting, denting, tearing, stretching. Okay, making solutions is another physical change. All right. Key feature of physical changes: the atoms are not rearranged. Chemical changes are usually reversible. Okay, you could take your paper and you could grind it up into a pulp again with some water, and you could put it back into paper, and then you could let it sit flat for a while, and you'd have your paper back. Okay, It might not look as pretty, but it would work. Okay. Evidence of chemical change, production of a precipitate. Okay. And you know when you produce a precipitate, we had this lovely chart from back in the day. Remember this guy? Yeah. So that tells you if you have your precipitate formed or not. Okay. You're not going to have to memorize it. There's just a couple things that you have to memorize it, and they're SNAP. We'll talk about it in a few minutes. Okay. Color changes are oftentimes, but not with dyes. Okay. So dyeing, clothing, coloring something, that's not. But oftentimes that's a sign. Frying an egg is a good example of that. Okay. You've got a translucent egg white, but it's not actually white until you cook the thing, but you have a very obvious color change there. Light being produced, strike a match. There you go. Change in temperature, again, strike a match. Sounds, strike a match. Evolution of a gas. There you go. Formation of new substances. Strike a match. Strike a match. Okay, so chemical changes are oftentimes difficult to reverse. There are some ones that you can, and some people even choose those for, I need to get you white out. You need to, some of the people even do those as their demos when we get into the end of the year where you guys do your demos for the elementary school kids. Okay. It's not working. It's not working. Should be working. Okay. Synthesis reaction here. A plus B gives you AB. Okay. We've talked about those back in the day. Decomposition, where you take something and you break it apart into the forms. I talked about how this guy here is kind of like It's kind of like marriage, and this one's kind of like divorce. Okay. Here, B is getting dumped, and A is coming into place. Okay. Down here, we have a double replacement reaction where, we'll just talk about square dancing maybe. That's probably a better analogy for that one. And then remember, you have your combustion reactions where you have oxygen present as part of the reaction. When we have a combustion of a hydrocarbon, carbon dioxide and water are always the products of that. Now, in the real world, there's one other product. But we don't do that one in here. It's rather deadly. Why do you open your garage door before you start your car? Carbon monoxide. So typically with a lot of hydrocarbons, you are going to get carbon monoxide as part of this. And that's just something to be aware of, especially like, we're moving into heating season. You want to make sure that your, vents and stuff are clean and ready to go as far as venting out that carbon monoxide from your furnaces. Okay. All right. Double replacement reactions also include acid-base neutralization and these precipitation reactions. We talked about neutralization reactions back in chemistry, and you actually did, most of you anyway, did a titration where you had your HCl plus NaOH. Remember that guy? And you formed what?
H2O.
H2O and what?
Yeah.
And NaCl. Yep. So you formed salt water. Okay. Did you get those? Did you get that whited out? So go and make 75 copies of that for me.
Okay.
All right. All of these can be considered redox reactions, except for the double ionic replacement reactions. We will get into redox reactions later. Okay, that comes at the end, towards the end of this unit, and you actually do one of these for one of your labs for this unit. Okay, so I do. You're going to try to figure out, and yours didn't come through as far as the colors, so you may need to like
Is there a certain printer I'm supposed to use?
I don't care.
Okay.
It's like the mixture.
75?
Yeah.
All right, I'll be back, never.
Just single-sided. All right, this is what? Same element bonded together. What is this?
Pure substance?
It is a pure substance, yes. What kind? What kind of pure substance? You had two. You had elements and you had compounds.
Element.
It is an element because it's the same thing. And this is one of 7 elements. What are the 7 elements that this could possibly be? Brinkelhoffs, yes. This would be one of your Brinkelhoffs. I forgot my nitrogen in there. Brinkelhoff. Okay, it's one of the diatomic elements. So that makes, and this is what state of matter. It could be liquid, it could be gas. Yeah. I would say probably gas myself, but yeah. All right, what is this guy? A mixture of an element and a compound. 2 different elements. So mixture of an element and a compound. And again, I don't know. I don't really like these diagrams for trying to figure. This is the only one that I would classify solidly as a solid. Everything else, I don't know if that's the best question to ask there. All right. Mixture, compound. Mixture of a compound and an element. Yep. Okay, what is this guy?
Pure compound.
Pure compound. Yep. So this is a pure substance. All right. What is this guy?
That's just a solid element.
Solid element. Yep.
That's just a break.
It could be like carbon. It could be, something lead, something like that. Okay. What is this guy? Mixture of 2 elements. Yes. Good. All right. Determine if each is a chemical or physical change. So it's evaporating. So what is this? Physical, right. Anytime you have a phase change, it is a physical change. All right, acid drops on my pants and a small hole appears.
That's not good.
It's happened. I've lost clothes to this profession before. So Jacob has a slideshow. He can show you what he's doing, and maybe you can work on one for 7th hour.
How many do you need?
I need 4 total. So I did 1, and then I need 3 out of you guys before you leave, if you can. Make sure you share them with me. Okay, So, small hole. What? Physical, chemical? Chemical, yes. All right. We got a precipitate forming. That is always what? Huh? Chemical, yeah. Dry ice. It's sublimating. Physical. Sublimation is a physical change. Yes. Is that it? Yes. All right. There you go. You got time to work on your homework.